Hey and welcome. Today we will solve night dialer interview question, so let's get into it. Here is the first example. What this question asks for is that based on the unique move of knight in chess game, if we were free to choose any place to start in a dialing pad like this one, how many possible ways we could have dialed based on the given digits count. For example, if we had one digit to dial, it is obvious that there will be 10 distinct ways to go for it. We could have just dialed any number on this trackpad. If we would have 2 digits to dial, there would be 20 distinct numbers combination that we could have dialed, and there they are. And if we have some crazy big number, then we would have some crazy big ways to dial this in combination of numbers like that. Let's see how we are going to solve this problem. The main initiative for solving this problem is more important than ignoring the fact that how many distinct places we can start dialing is the potential on each number that based on our L-shaped move would lead us to the next location to go. If I put this in more simpler form, as problem says, we only need to move L shapes, right? So if we get a number that is 5 digits long, whatever number we choose to start will lead us to another number on the path, right? Then from there on, we have 4 more moves to make in order to complete the dial, which means doing the L move again, landing on another number, and then having 3 more moves to complete, and so on. You see sub-problems here? We are exactly getting same problem in a smaller scale to tackle. This is where dynamic programming comes into play, but before more on it, I need to mention 2 things. First is, remember, as a base rule here, we can only do L moves. Then how we are going to know where to land on each number as next, considering that each number can have multiple choices to go as next value, like look at 6 here. For that, since we are dealing with a keypad only with 10 digits, we will not going to find the next location for each number on the fly. We will keep a valid states of next location for each number in the keypad based on an array indices that will map to the digit on the pad, because this state is not going to be that big to be worried about. That is kind of one piece of puzzle to solve this problem, plus saving a few CPU power on runtime. The second thing is, we are almost forgetting one big thing that problem mentioned for us. We literally can start from anywhere in this dial pad. Now here we go, we might sum all possible starting points from this dial pad. That is another thing to think about, because that would give us our final result, not only following one pass based on a digit, but it brings us to one important question of what if we get some big number to dial, like this one here, because look at the end limitation here. It could go up to 5k. You see how big of a possible moves we are talking about on longer numbers to dial? I mean, as the count of numbers that we're supposed to dial grows, the number of possibilities of moving from each number to another just grows in a very big scale, since each of those numbers has still some remaining digits amounts of possibilities as next number to go to, and each of those form their own paths. Plus, since we might supposed to consider all of these possibilities starting from any of those 10 digits on dial pad, the amount of possibilities would skyrocket, right? So 2 factors involved on each possibility: the possible next move for each number we choose, plus the initial location to start dialing. And as the number is big, these possibilities just grows, and you know the story. That would cause us to hit our computation limits, things like overflow and problems in that category. So you might already guess probably that is why question says take care of the mod for bigger numbers. But it is not just that. If we think about a recursive way, we need to involve caching as well. I'll show that to you in a code in a bit. Okay, let's recap here to see what we need. We will have a recursive function that in bare minimum, it will take digits amounts to dial, and it will break out this into sub-problems until it reaches to the base case, meaning when we have no more digits left to dial. Meanwhile, we need to keep track of 3 things when we want to dial a number. First is, on each number we dial, there are multiple passes to go for that will end up us in a different end results. Second is, while doing this, we might sum the results of every possibility, so we will take care of it as well. And lastly, the caching part. Along the way, we will cache the values we compute through the recursive calls in order to prevent the time limit exceeds issue. So let's jump into the code to implement it. Here we are in Leetcode. First thing is, we will have a wrapper function that will invoke our recursive DP function. We will call it main and return whatever result it gives to us at the end. Now within this, we might create a variable that holds the sum of possible forms of dial paths for each number on numpad. We will call it result and return it at the end of this function. Now for each of the numbers on keypad, we will sum all of possible dial combinations that each digits may form based on the chosen number. So who is responsible for giving it to us? The recursive DP function that we'll write next. Okay, we will pass 2 things to this recursive function. First is the digit in the iteration. The second is number of remaining steps of dial process, but we will subtract 1 from it there because we are already chose one number, the digit on pad variable or starting point. Next up is the recursive function itself. So as we discussed, when we run out of numbers to choose from, we should stop this recursive call. So if remain is 0, we might return one possibility, meaning we are done with that pass that we formed so far in this recursive call stack. If we are not in base case, definitely we are deciding on choosing the next digit to dial. So that means we will have multiple possibilities and we might sum them up as return value for this recursive call. And because of that, we might have a for loop and dig the path that each option will make us to pursue with our recursive call. So here we have a requirement to those valid states of possible options to go as next location. So we might generate that jump state first. I will just copy paste it here because it's too long to write. And with help of that, we will add up the possibilities for each option per number we choose as next. Now, if I run this, it will pass for smaller numbers, but it will fail for bigger values. Here we go. We get time limit exceed because of test case number 3, which has a big number. But let me lower it to 10 and see what's going on here. Now, if I run it again, you will see it is passing. But just for a 10-digit number, we have about 15k possible ways to dial. So imagine how big it could be for initial value of test 3. It was 3131, right? And how big amount of computation, especially repetitive computations we are talking about here. So long story short, to overcome this time limit issue, we will mod the results and also implement the caching mechanism. First, let's handle cache. We might have a cache store called memo, which will be responsible for holding the states of DP calculated values for next repetitive calls. This 2D array will hold 10 possible states for each of digits count we might dial. We use n+1 here because considering the number of remaining moves the knight has, meaning it can be from 0 to n, so we need n+1 slots to store solutions for all possible cases. Next up, within our DP function, if we already calculated the DP state on remaining moves based on the digit we have, then we might return it immediately and don't compute it again. Otherwise, we might add whatever we are calculated to the cache before we return. So that was it with caching part, but what about the mod part for bigger numbers? For that, first let's define the mod key as problem's description. We will take care of it once in each DP call that we make and once within the main function when we reassign calculated outputs to the result variable. Now if I run this, tests are passing, and if I submit, we are in a good shape here. Now let's jump back into the slides for time and space complexity analysis. The time complexity will be O of 10n because we have 10 digits on the pad, so there are 10 possibilities to form the dialed number, basically 10 times n possibilities. But eventually it will end up being O of n because constants does not matter in terms of time complexity representation. And the space complexity will be O of n because of our recursive calls to the top that DP function makes, plus the memoization also happens along the way. So that was it for this video. Thanks for watching, and please leave a like, comment and subscribe to the channel. I will put a few more links about different playlists in the description for you to check it out. And finally, hope you enjoyed this video and stay tuned for the next one.